Hello everyone. So good evening, good afternoon from different regions. Thanks for joining the second call of SIG operations meeting. So we have three topics for this meeting today. The first topic is basically about the Cloud Foundry at scale. So maybe I can give it over to Bernd to right away kickstart the meeting with the Cloud Foundry at scale. Over to you, Ben. Over to you, Bernd. Yeah.
Okay, thanks, Gauri. So actually, I'm not going to present alone, but Jens Hüsken, a colleague of mine, is also in the call. We are both from the SAP Cloud Platform development organization. Jens is an area product owner there, and I'm a technical lead there, and we are kind of pairing up to work on the topic of Cloud Foundry overall. And I guess, meanwhile, we also can claim that we are running some of the biggest Cloud Foundry deployments worldwide. And in this presentation, we want to kind of summarize our learnings and experience from bringing Cloud Foundry to scale, and essentially also share a little bit the topics that we hit while we are in the progress of scaling Cloud Foundry. So with that, let's right away jump into the topic. And there's actually a couple of dimensions if we talk about scaling Cloud Foundry. Then one aspect to actually look at is like how many Cloud Foundry foundations, so Cloud Foundry deployments, does one actually need to run? And as that is essentially also a topic of regional coverage. So where are your deployments located? That is definitely one thing there. But then also we are running SAP Cloud Platform on top of the various hyperscale providers. And, we'll talk about that in the next slide in a little more detail. But that also for us brings additional effort and challenges in terms of scaling our offering. But then last but not least, which is also a major focus of this presentation, it's also about scaling up a single Cloud Foundry foundation. So one deployment that at least we for SAP Cloud Platform run in a multi-tenant fashion for many of our customers. So by and large, these are kind of the big dimensions that we need to look at. And now we're kind of diving in a little bit in each of those. So if we look at how we run SAP Cloud Platform, then this picture here pretty much describes the various locations, but then also data center providers that we offer SAP Cloud Platform on. So the orange one is SAP owned data centers, and then we essentially have a presence on the three big hyperscalers, AWS, Azure, and Google Cloud Platform. And because SAP Cloud Platform kind of not only consists of Cloud Foundry, but its origins actually date back pretty much back in time to a similar point in time than Cloud Foundry was initially created. We kind of have data centers that don't have Cloud Foundry, but as you can see from this visualization, we also have quite a few data centers that meanwhile run Cloud Foundry. And we are also in the process of essentially taking a look at that metrics of data centers, seeing where we need to build up additional regional coverage. So that's like talking about global distribution, that's roughly the scale that we have there. Then next one is essentially talking about like why is it a challenge to have that number of foundations, that number of Cloud Foundry deployments out there in the wild, so to speak. So it's a challenge on a couple of fronts. So first of all, it's a challenge in terms of monitoring. So like obviously, if you have one foundation, you need to monitor that. If you have multiple of those, you need to make sure that each of those are healthy. So the question is essentially, now that you have built your monitoring for one foundation, how do you scale that up? How do you make sure that your operations teams can actually monitor that whole set of Cloud Foundry deployments that I've depicted on the previous slide? Then also, because as I said, we are talking multiple infrastructure providers, this is also a challenge in development, because like, yes, Bosch is a tool that we definitely use quite a bit to manage all those deployments. And those deployments not only contain Cloud Foundry, but they also contain things like backing services, things like applications that we as SAP provide to our customers running on top of Cloud Foundry, et cetera, et cetera. And so in development, we need to make sure that like all those different infrastructure providers are actually supported in the same way. So our strategy is to have the same Cloud Foundry versions rolled out on all those infrastructure providers, the same features enabled, et cetera, et cetera. So that roughly describes the challenge that we are facing in the development organization. And then obviously, like, it's not only enabling those functionalities, but then it's also about how do you test that stuff, and then ultimately how do you update all those landscapes, because for each of the spots that you saw on the previous world map, you can essentially imagine that these were quote unquote only our productive deployments, but then for each of those productive deployments, you have a set of deployments that are used for qualification, that are used for testing hot fixes, et cetera, et cetera. So it's kind of the world map that I've shown previously. It's just a fraction of the number of Cloud Foundry foundations that we need to manage. And then when it comes to updates, we are essentially running a staged approach where obviously we qualify new updates to those foundations internally first, and then we roll it out across the hyperscalers, across the regions, et cetera, et cetera. And then obviously it's not only those major updates, but then and I guess everybody running Cloud Foundry deployment productively knows that there's also every now and then the requirement to basically patch those foundations, and those might be functional fixes, but those are also, and this is where it gets time critical, fixes for known vulnerabilities that are, for example, coming in via the Cloud Foundry security response process. So as those fixes are sometimes time critical, having that number of Cloud Foundry foundations poses another challenge there. So that kind of describes roughly what we are facing in terms of infrastructure providers and then also regional distribution. By the way, I forgot to mention, if you have questions at any point in time, feel free to interrupt. And
yeah, ask. So maybe Ben, one remark here is as well that we kind of try to stay on the latest CF deployment versions, right? And we do that in every other week to consume those, and that's also a major challenge in development to do that on 5 different IaaS providers, right? So this is definitely also a challenge we have. And when it comes to patches, it also means that you have to document what you change in the system. That's not only true for patches, but also for updates. And here, if you have your platform certified, like you have ISO or SOC certifications and so on, you also need to have proper change management processes in place, and so on and so forth. Just to add those points.
Yeah, thanks, Jens. Important points that you brought up there. Yes, definitely. So then, what is the size of a single foundation? So now that we have kind of briefly touched upon what is the challenge with multiple foundations, let's dive into the size of a single foundation. And these numbers here, actually, we took them for the Cloud Foundry Summit, where Jens had a presentation during the unconference, talking very briefly about the topic of Cloud Foundry scaling, and this here are the numbers that we published back then. Actually, I looked at the number of service instances coincidentally just an hour ago, and I can definitely tell that number is growing immensely. So, and the same I think is true for the other figures that we've provided here. So definitely we have quite some uptake in terms of people using our offering, and that is both SAP teams that are developing and deploying and operating their solutions on top of our SAP Cloud Platform, Cloud Foundry offering, but it's also external customers that are using our platform. And that kind of the remainder of that presentation is around the challenges that we face with those numbers that we have depicted here growing over and over. So what are kind of by and large the rough categories that we see when we talk about the size of a single foundation? Where are the challenges there? So first of all, and you've seen like the number of CPUs that we have, which you can then roughly translate to the number of virtual machines that are running there. Reality is obviously creating and deleting virtual machines just takes time. And the way how Bosch does updates today obviously means that you request the infrastructure layer to create a set of virtual machines, which then, depending on the underlying infrastructure, takes a couple of minutes. Then you bring the software on, you retire the old virtual machines, and then you do that in a rolling update fashion. And those updates really take their time, and we're talking about multiple days ultimately until a system is fully updated. So that is one challenge that we are facing, and that's the result of the sheer size of the deployments that we are running. The other area where we are facing challenges is the scalability of Cloud Foundry components themselves, and we've just provided here again some rough headlines around things we have seen while scaling up our landscapes. So one factor that's majorly influencing the topic of scalability is the KPI of number of Diego cells. So based on the number of Diego cells, you'll see some interesting effects if you scale that up and up. And consequently, obviously, like with the number of Diego cells that you increase, you also increase the number of application instances that are running on those Diego cells. And sometimes we see effects where it's really the sheer number of application instances that makes a difference, and ultimately, if you scale that further and further, will lead to outage situations on the landscapes. But sometimes we've also really seen the number of Diego cells factoring into a certain calculation, and then by experience, you learn like this is the number of Diego cells that you can safely run. And as soon as you hit that number, you need to figure out what to do next, essentially. And we'll see later on in the slides one kind of countermeasure that we have taken to counter the growing number of Diego cells. The other area that we have seen is in the area of Cloud Controller. I would say Cloud Controller in general, but then specifically how Cloud Controller talks to the underlying database that stores the information of Cloud Controller. And there we have seen challenges with the number of database connections towards that Cloud Controller database. And here, kind of hidden behind number of database connections is obviously also the question of how many Cloud Controller instances do you actually run, because each of those Cloud Controller instances will open up their own set of database connections underneath. So that is a factor that we have seen. We have also seen issues in the Logregator subsystem. And one factor there, again, is like how many applications do you actually have, and how much logs do those applications actually write. But then also, and I guess many people running Cloud Foundry at scale have seen this as well. There's also always those single applications going crazy, like for example, because they can't connect to their database, and then they keep trying connecting to that database, but keep failing. But then the result is that you also write something like a Java stack trace in a very nice periodic rhythm every couple of milliseconds into the log. And so then the question is, how do you kind of make sure that that single application going crazy is not overloading the entire logregator subsystem? Another aspect that we are currently looking into is container networking, because also there the number of application instances, and specifically the number of application instances using container networking, factors into some equations. And then again, there we are gaining experience around what a reasonable number of applications using container networking actually is, and when the system then kind of goes critical and starts failing. CLI and tooling is another area. So if you, like us, have thousands and thousands of Cloud Foundry organizations and Cloud Foundry spaces and service instances and applications, then you will definitely also notice that certain command line interface interactions take quite a bit of time. And part of the reason we have found is what I would call suboptimal SQL statements that are kind of the result of the fact that Cloud Controller underneath uses a Ruby-based OR mapper to generate those SQL statements, unless you do something special there, and that SQL statements that are generated are not always optimal, or there's maybe also sometimes trivial things like indices, which you would need to accelerate those statements, are not in place, so things like that. But then also, and that depends on the particular CLI command, you come in situations where the CLI needs to trigger a set of Cloud Controller calls, which then again cascade into quite a huge number of SQL statements towards the database. And we've seen issues where, like, the CLI could also be optimized to actually trigger less calls towards the Cloud Controller in certain situations. So that's an area that we have seen. And then last but not least, as we are running on the big hyperscalers, and the big hyperscalers obviously know their limits, and they introduce things like rate limits and quotas to make sure that no single customer of that hyperscaler is kind of abusing the capacity that they've paid for. We've also seen us hitting things like rate limits, which means essentially the number of API calls towards the hyperscaler that you can do in a particular time unit. And we've seen that in particular when it comes to updating our landscapes and using Bosch extensively to do that. But then also quotas, like how many disks can you actually have in your account? What is the number of VMs of a certain size that a particular hyperscaler can provide you in a certain region? So things like that also factor into the overall size of the Cloud Foundry landscape, and those are boundary conditions that are imposed by the particular hyperscaler. And then last but not least, there's also unexpected behavior. So like for those KPIs up there, we kind of know that there are limits, and like this is what you need to watch over time and gain experience and find ways to either work around those limits or push those limits, etc., etc. But then there's also unexpected behavior where things looked relatively good at a certain point in time, and then from a very surprising area, from a component maybe that you didn't even have on the radar, you essentially find out that there's some unexpected behavior exhibited, and then you essentially also run in outage situation, which are obviously unpleasant, because as soon as those outage situations happen on a productive system, you essentially need to react very quickly and fix whatever issue has been created. And that can be as simple as, again, scaling out particular components, but it could also be as complicated as you need to have a fix in one of the components that make up the overall Cloud Foundry landscape. So those are roughly the areas that we have observed there. Then just to kind of mention one topic that, as I said earlier, we have seen a number of Diego cells is something that kind of moves Cloud Foundry foundations into a critical state. So thinking through what we could do to kind of reduce the number of Diego cells, and this is like something that I believe many people coming in those scaling limits are also thinking about is, can't we just have bigger Diego cells so that each Diego cell can actually host more applications, and therefore we can again reduce the number of Diego cells. And here without any like X or Y axis depicted there, but the orange system is our canary system, so our internal system that is used by SAP teams to develop their applications. And then the gray line down there is our European deployment of our biggest foundation there. And you essentially see the number of Diego cells steadily growing until the point in time where we said, okay, let's double the number of CPUs, let's double the number of RAM that each of those Diego cells has. And then essentially you can see the number of Diego cells dropping down again, but then obviously as usage continues to grow, you also see that like this particular maneuver has its limits. And so the question is what the next step will be once we hit again those upper limits that we have perceived so far. So that's one kind of concrete countermeasure. You could also call it a workaround to essentially work against some of the scaling limits that at least we have seen. So then, like, you also come into a more substantial conversation around what are the options that you actually have to basically scale up such a Cloud Foundry deployment overall. So assume that you have Cloud Foundry, one single foundation running in a region. And then obviously, as I also mentioned before, that there's a certain set of measures that you can do to extend the limits of that single Cloud Foundry foundation. And one of the short-term measures we've just seen on the previous slide, just double the size of the Diego cells and therefore buy some time until you again hit that critical number of Diego cells in a single foundation. So this is something that we definitely do. Then doing synthetic scalability tests is another area that we are intensively working on, and there'll be a follow-up slide to talk a little bit more about that. Then obviously Cloud Foundry has a functionality called isolation segments, which essentially allows you to slice a single Cloud Foundry foundation into pieces, and those pieces are independent. So for example, when it comes to Diego cells, so each of those isolation segments has an own set of Diego cells that are associated to it. That's kind of the smallest version of an isolation segment. The slightly bigger version of an isolation segment also can isolate things like the ingress to the system. So components like, for example, the Go router can also be sliced into one or more smaller deployments, and therefore some of those critical numbers when it comes to number of Diego cells, for example, you can counter by introducing those isolation segments. On the other hand, isolation segments still have a set of common components. So things like, for example, Cloud Controller or also the Logrator are components that are still considered central for isolation segments, which means you cannot slice those. And if you hit limits on those components, then isolation segments are not a means to counter those limits ultimately. And then last but not least, and this is because it's open source, this is the way you should be doing things. We are also active in terms of pushing the scaling limits of individual components. And that obviously also has a set of ways how you can achieve that. So Even if you don't know the ins and outs of a particular component, one thing that you can definitely do is talk to the corresponding PM of that component in the open source and make people aware of the issues that you have perceived, that you have seen in scaling a particular component. And we have done that for a set of Cloud Foundry components, and we keep updating the PMs of those components as we find new or as we uncover new findings for those components. But then also, and this is obviously in particular relevant, if you know the coding of a component, you can go in and obviously also file your own pull request, make things better, work against those scaling limits by putting in fixes. And then ultimately, and this is why there's also a second set of measures. Ultimately, you'll find that each and every component has its architectural limits, and once you hit those, then I guess you are essentially up for a major rewrite of that component, unless you have other means. And the other means that we are also actively looking into is scaling up an individual region by putting in new Cloud Foundry foundations into that region. That again has an own set of challenges, because at least we need to make sure that each of those Cloud Foundry foundations essentially has the same set of services in the Cloud Controller service catalog. So that is at least one topic that we are actively looking into. And where we have with the open source component called Pariply, or also oftentimes referred to as a service manager, a means to quote unquote distribute service catalogs across multiple foundations. So this is something that we're working on. But then also we have things like a common user interface that we call the Cloud Cockpit for all the users of our SAP Cloud Platform, Cloud Foundry offering. And there, one challenge is to point each and every user to the foundations has an own AI. This user I talked about, for a user that is just logged in, what is the endpoint that this user needs to work against. So that's one topic. And then ultimately, if you say, let's go down the road of having multiple Cloud Foundry foundations in one region, the most extreme form of that is to say, let's just give every customer an own Cloud Foundry deployment. And this is essentially where one of the open source projects that we have originally kicked off together with IBM and SUSE comes in. So that's the IRINI project that was also talked about quite a bit during the last two Cloud Foundry summits. So essentially that idea of saying, can we deploy Cloud Foundry not on virtual machines, but instead on top of Kubernetes? And that has, I guess, a set of benefits that we don't have the time to go into in this presentation. But one benefit is that by having Kubernetes as an additional scaling layer, you essentially have a more lightweight Cloud Foundry deployment to basically run. Now, obviously, by putting Cloud Foundry on top of Kubernetes, you buy yourself some new challenges, which is then you need to manage Kubernetes clusters. And usually you would say, if you have multiple customers, then basically you also need to have multiple Kubernetes deployments or Kubernetes clusters for those multiple customers. So there's always a trade-off, obviously. And then this is something that we are also actively exploring at the moment. So then I already mentioned that we are running synthetic scalability tests, and this is kind of a rough picture of what we have done in that area. We have set up a project that essentially had the purpose to say, we know how big our biggest Cloud Foundry foundations are today. But in terms of scaling, we don't want to see issues only once we update those Cloud Foundry foundations to a new version, but we want to kind of get a preview of the issues that we are seeing. So we need to have an own, what we call scaling landscape or scaling foundation that kind of gives us that preview and that we run independently from our productive deployments. We started by saying, let's take our canary system. So essentially our biggest system that's used SAP internally as a baseline in terms of like certain KPIs, like how many Diego cells do we run, how many application instances are we running. We use that baseline to then exercise an update process, because as I've also mentioned in one of the previous slides, update processes, update procedures are one major source of issues when it comes to running big Cloud Foundry foundations. So by updating that baseline system and bringing in a new version, we gained experience regarding the issues that we were facing during that update. We can say that today this system has twice the size of our canary landscape, which, as I said, was so far the biggest landscape that we were running. So by running twice the size of that canary landscape, we obviously want to create some wiggle room for us to say, okay, this is how far we can scale a single foundation, kind of knowing everything that resulted from those scalability tests. And then the next step that we want to do once we have tackled the issues that came out of running the landscape in that size is we want to go beyond triple the size of our canary landscape. So that's like roughly what we do in terms of synthetic scalability tests. And then last but not least, and this is indeed the last slide of the presentation, also a bit of kind of insights into what we found during those synthetic scalability tests. And for two of those issues, I've also linked the corresponding GitHub issues that we have created. So similar to what I mentioned earlier, we've seen issues in that scaling landscape in a couple of areas. So one is BOSH, or kind of update processes in general. We've seen timeouts, especially when we were recreating many instances in parallel. And there's a GitHub issue that where our BOSH team, our open source BOSH team, that is also co-located here in Waldorf in our headquarters, actually worked on fixing that particular issue. So we obviously make sure that we bring those fixes back into the open source. And I think that has also been mentioned by the people from Telecom during the Cloud Foundry Summit in Philadelphia. We keep looking into the topic of no ops when doing a BOSH deploy. So essentially BOSH ultimately finds out there's actually nothing to change, like there's no new versions, no new VMs need to be created, no old VMs need to be deleted, but you're waiting X amounts of minutes for BOSH to actually figure that out. Our BOSH team is still looking into the topic, and I believe we already contributed some optimizations upstream. Still, that X in X number of minutes is quite big, so the team keeps looking into that topic and has a couple of ideas on how to improve that even further. On the other hand, there's also the workaround, obviously, to say let's split the BOSH deployment that makes up the Diego cells into multiple deployments. So there we've essentially started by splitting CF deployment into two. One BOSH deployment that is updating the Cloud Foundry control plane, and then another BOSH deployment that is updating all the Diego cells. The next step that we want to look into there is splitting that BOSH deployment containing all the Diego cells further into reasonably sized chunks, so that basically each of those chunks can be updated in a much smaller time. So that's something that we are currently looking into. looking into scaling Cloud Foundry, things that we've seen there is Diego drain scripts that essentially never end, where ultimately Bosch had to forcefully shut down the Diego cells with those hanging drain scripts. And there's another GitHub issue related to that. And then we have seen, and this is just one example, and we could name a couple of more there as well. We've seen the Diego scheduler using more CPU cycles than were actually available on the VMs that we deployed it to. So one countermeasure there is obviously, quote unquote, just buy bigger virtual machines and make sure that the Diego scheduler has more CPU cycles free to do its job. And then under general, there's a set of other Cloud Foundry components. So one component that's actually not part of CF deployment, but is still part of the open source, the HA proxy, which exists in the form of an HA proxy Bosch release. When we were putting load on the system, and in that particular case, load in terms of number of requests that are calling Cloud Foundry applications, then we have seen certain situations where we needed to scale our HA proxy Bosch deployment, and scaling meant scaling on various angles like disk sizes, again, size of the virtual machines, etc., etc. So that's something interesting to look into. Our monitoring of those system landscapes also at times couldn't cope with the number of metrics and the frequency of metrics that were reported by all the underlying Cloud Foundry components. So we had to scale that up. And then last but not least, as I mentioned, scaling the Logregator infrastructure depending on the load that's put on it by the Cloud Foundry applications that are running there. So with that, that kind of completes the tour of scaling Cloud Foundry in terms of trying to summarize our experience with the topic. Therefore, we were also very happy to hear during the last Cloud Foundry Summit in Philadelphia that there's more companies that are starting to see those scaling challenges, which is also, I think, a good reason to continue exchanging information on the Slack channel that has been specifically created for people that are interested in the scaling topic overall. With that, that's the end of the presentation. I would open it up for questions. There doesn't seem to be any. So I guess, Gauri, back to you.
Yeah, thanks, Bernd. Yeah, it was a very good presentation. Yeah. So if there are no other questions, yeah, maybe we can jump into the second topic. It's more of an open discussion. If Aaron in the call, so I don't think so. I find him. So there's a topic from Aaron. So basically about so thoughts on leveraging encrypted certificates for Go routers in general. Yeah. So if someone have any pointers, some thoughts on this topic, so maybe yeah, we can start discuss on this topic.
We'll jump in. My name's Richard. I work at gov.uk PAS. We use Let's Encrypt for a lot of our production services. We don't do them at the Go router level. We do them at, it's on a CloudFront instance. So we put CloudFront in front of an Amazon ELB, which is in front of an HA proxy, which is in front of Go router. So there are Let's Encrypt certs in our case, but they're managed quite a long way away from the Go routers. I'm not sure if we'd expose Go routers directly. I think we'd always put some kind of load balancer in front of them. I'm not sure if that's exactly the idea that Aaron was raising though, a different team.
Well, I think like our experiences of trying to automate Let's Encrypt is it's surprisingly difficult. Like we've seen a whole bunch of failure cases where like a lot of the libraries for interacting with it aren't really designed to be run in a like server fashion. They're kind of written to be run by hand. I guess like you totally could do it, but like again, if you're giving those certs to go out to itself, I guess you then go back to why aren't you using a load balancer and giving it to those? Like, I wish Aaron was around to explain exactly what he was after there.
Gauri Shankar, it might be worth reaching out to Aaron and see what exactly he was trying to get or what exactly was his question so that the folks from the government UK, Richard and Mikey, can maybe have a follow-up Slack discussion.
Yeah, sure. I already pinged him. Unfortunately, he's not there online. So maybe, yeah. So I can ping him offline and then check so what exactly he was trying to look into it. Yeah.
Yeah.
Sure.
And thank you, Richard and Mikey, for jumping in.
Yeah. So the next topic would be, so basically we put this topic, so we wanted to understand in general, so how the availability of the Cloud Foundry platform is being measured. So what are the factors in general should be considered, so when you say cloud platform availability. So also I got some feedback from the community itself. So let's say someone, if you're measuring the cloud platform availability, so in general they will measure, let's say the API uptime and then the staging availability. Let's say if you're using any services which you are able to bind to the Cloud Foundry applications, and then let's say the broker availability, app availability. So these are the most important things in general. Anyone who is running the Cloud Foundry platform will measure it. Yeah. So apart from this, so anyone thinks, are there any other important metrics, okay, which we should consider when you say the platform Cloud Foundry platform availability? Yeah. So maybe some inputs on this one.
We'll jump in again just to say that we don't think we're very good at this. We have, like, what we'd like to say to our users is that we have an uptime service level agreement of say 99.99%. And some places we do say that, but we don't exactly know what we mean by it. So we attempt to monitor application uptime basically by pinging some apps and seeing if they're up. We also attempt to measure API uptime by pinging the API and seeing if that's up. But a lot of the platform could be broken in a way that our users would not be happy with, and those metrics would still be at 100%. So for example, the entire logging pipeline could be broken, and our metrics would still say everything's up. You could be unable to push an app, and our metrics would still say that everything was up because they don't actually touch that bit of the API. So it's something that we're looking at, but we have not got any easy answers yet.
Yeah, I'd say like one of the really messy points is like, so we provide like Postgres databases and things to tenants. So obviously like the uptime of that is completely variable depending on each instance. We have like no ideas on how to monitor all of those in a way. It's difficult. We'd love ideas.
Okay, so that's the unmute button. Thanks. This is Andreas. When you say you ping the API, that means you really just check if the API endpoint is available, or do you really try a round trip, trying, let's say, to do a CF login? And if you do a CF login, do you take a CF UAA user, or do you take a user which is coming from a different identity provider?
We have both actually, but the thing that we use to generate the nines is just pinging the info endpoint.
Okay.
we also have smoke tests which actually push an app, I think.
Yeah.
So we would notice if people weren't able to push apps.
Yeah.
We'd notice and say it's down, but our metrics would still say it was up.
Yeah. So one thing that I'm wondering is, so if you want to have a single number to say I'm up or down, then you really have to simplify a lot, right? So if you would say, okay, I measure everything that you could measure, then it's probably hard to reach a lot of 9s. If you go to something totally simplistic, then yeah, you as you said, right? You say I'm 99, I'm up, but your customers might experience some down. So what we tried at some point in time was like doing some scenarios that we say this in this kind of scenario, this is up and running. Also, have you played around with something like this? You said, if I got this right, that you also tried some pushing of apps. So like that, which is let's say already a bigger scenario because you have quite a lot number of components you have in there, quite a number of interactions that go through the wire.
Yeah, so we have a bit of that. We're sort of starting to look at how to monitor, how to get the sort of middle ground between absolutely everything's working, which is sort of what our smoke tests do at the moment, or at least the main things are working, and like maybe some things are working, which is what our 9s say. So we're sort of currently trying to move the needle a bit towards a more realistic view of our uptime. But there's lots of different things that we're doing, but we're very early days, so I don't think it's worth going into much detail.
When you describe like defining scenarios, is that like so you can look at like common use cases for the platform and look at how often will these people have problems?
Yes, so basically one scenario we played around with, or actually also use that internally for us as a team, just as an additional sanity check, is for example logging in, pushing an app, binding services, starting the app, seeing do we see logs streaming, and can we actually reach the app, and can the app do a successful communication with its backing services. So let's say something where you're pretty sure that this app is working because it has worked a couple of thousands or million times before. But let's say working with this, there are so many things in between that could fail, right? That it's this kind of check doesn't immediately tell you what is probably broken. Or is it the monitoring which is calling which is broken, or is it actually the platform that you're testing, and so on. So it took us some time to stabilize it for ourselves, but it's not, let's say that we say this is such a einleuchtend, okay, English words, such a immediately intuitive way of monitoring a platform that we say this is a really good measurement. As Govri asked the question, okay, how do you say you're up or down? This is just one aspect of it. We find it helpful, but how do you say have a crisp explanation of what you're testing there? Okay, you seem rather muted, but maybe that is a discussion to let's say do on a little technical terms in the Slack channel to say, okay, these are the steps or so on, to just see what are your thoughts on that, because basically if that is something where we can say this is a good scenario to say this is a most simplistic developer round trip or so on, that could be one interesting measurement that you probably don't say this is SLA relevant, but that's at least something where you say that is a good health check that you want to implement as a Cloud Foundry provider.
Yeah, we'd certainly be interested in discussing more offline, I think.
Yeah.
Just a quick point for Cloud.gov, we make the distinction between customer application availability and customer access availability. So basically it's, are your apps up and running, which they generally tend to do in a lot of fail cases on Cloud Foundry, yep, because Diego cells continue to run this stuff, versus there's something wrong with CAPI or brokers or something like that. So by distinguishing those things, it's much easier to talk to people about like uptime of your applications versus like, you know, hey, sometimes we'll have scheduled maintenance for these other things, or, you know, hey, looking at our record, the problems have always been and like CAPI scaling, and like that's been an issue, but it hasn't been a problem for application availability. So that making that distinction seems to have been like just that those two things seems to have been very helpful for talking to our customers.
So sometimes you say runtime and lifecycle management of your applications, so to speak.
Yeah, something like that. I'll have to look up the actual terms we use.
Yeah. Okay. Yeah.
Do you know, Brett, how you actually measure your application uptime? Because at the moment we just check like a single static app, check that that's fine. But a lot of apps on the platform could be broken, we wouldn't notice. So do you check like actual production apps, or do you have some sort of smoke apps that you use to check a representative sample? Or
yeah, we're running the smoke test basically constantly in production. So the way we term it on our status page is cloud.gov customer applications and cloud.gov customer access. And those are further broken down into specific things in each of those. I'll put the link in the CF operators channel to our status page. I will caveat this by saying that our status page, like this is our human communications tool. This is not like our monitoring tool. So this is not like, you know, we might see alerts on different things, but that's not feeding this data. This is about like when is a customer observed or customer reported outage happening. So I guess I'll stick in the chat here and in the channel. But again, just like for communicating with customers, like this is a logical breakdown they can get behind because they understand better, like, okay, you know, what is your track record and what am I going to see?
Okay, so is there any other inputs on this topic? Okay, so if there's no, so we can jump into the another discussion. So Richard, can you take over?
Yep, us again. Sorry for talking a lot. I just thought we'd mention this because we had a recent issue with it. We use CF deployment to manage our Cloud Foundry deployment. There's obviously a lot of certificates in there, and there's quite a lot of certificate authorities. And from time to time, we need to rotate some certificates, or we need to rotate some certificate authorities. And in the early days when we were getting everything set up, we did some work to make it so that we could rotate either certificates or certificate authorities in a way that didn't cause any downtime for our API. So it's possible to sort of roll them out gradually. But the way that we've done it has ended up taking a long time, and it's become more and more painful as our foundation has grown. And we're now getting to the points that were mentioned at the beginning of the presentation about like it takes us maybe 4 or 5 hours to deploy a foundation. We have to deploy it 5 or 6 times to rotate the certs completely. So we're talking about like a couple of days of work, just like constantly change a little thing, deploy a little thing. I was wondering if anyone has a better way of rotating certificates, or if there's any prior art that we're missing, perhaps.
I guess we think we can do it in fewer steps, but what's frustrating us is that we have to script this at all. Like it feels like the kind of thing that CF deployment should offer, but as far as we can tell, it doesn't.
Yeah, I guess same thing for us. So we also have to script it. So that might be indeed worthwhile to kind of exchange experiences on what works and maybe what doesn't. Seen interesting situations.
One question. What I still did not understand is why you do not use an external root certificate for all these internal stuff. This would at least help you to get rid of exchanging or replacing the trust every time. So maybe it's not possible because the CAs can then not be generated inside the landscape, but maybe it's easier to have some CAs replaced by using an external CA than having multiple steps to rotate everything.
I guess like You make a really good point. So the CAs would then presumably change less regularly, but then we'd still have to be copying and pasting new certs, where right now we have a big YAML var store that we put them in. I guess it feels really painful. Like we have scripts that are moving things from like particularly name keys to that key name underscore old. I guess it's like if you were manually editing the YAML, it would make sense, but from a scripting point of view, it's quite painful. Yeah. Oh, cool. I see Swan has just said that this is recorded, so I guess we can show this discussion to that team.
Yeah, all the calls are recorded and we put them on the YouTube channel. So we can mention it to the broader team, and also Brett, you can probably ask your team to weigh in as well. Once they hear the recording, they can weigh in on the Slack channel. But it might be worth mentioning with the release integration team as well, because it seems like a consistent issue with, consistent kind of requirement across all the teams. Yeah.
Cool. I think that's it for us. We just wanted to check to see there wasn't a magic answer. It sounds like there isn't.
Yeah, I'll paste some links to what we do in the channel, but like we can chat about it in more detail as well.
Yeah, cool. I know that we are we are at the top of the hour. So was there anything else, Gauri Shankar, that we were supposed to discuss on the call today?
I think, yeah, so we don't have any other further topics. Yeah, we are done for the meeting. Okay. Yeah.
Cool. I will process this recording and post it on the YouTube channel. I'll also update the Slack channel once it is up there. And I do apologize for the time zone confusion and the dial-in confusion that we had this time. It looked like we were split on two bridges. So thank you, Mike, for pointing that out and tagging me on Slack. I will fix those two issues for the next call. But this is good. Thank you very much, Gordon, for starting this and leading this. Thank you all for participating.
Thank you all very much.
Yeah, thank you. Thank you, everyone. See you on the next meeting. Bye-bye.
Have a good day. Bye-bye.
Bye-bye.